evening and welcome to NewSpace Chicago. We are an open community of space entrepreneurs and other people who are interested in developing space ventures, companies relating to space located in Chicago, which is kind of an odd thing if you think about it, but we believe Chicago is actually a good place for startup companies in the space industry. We're an old manufacturing town, have a vibrant manufacturing economy here. We are a transportation hub for the entire country. We're actually a global financial center. We have world-class universities and research institutions and highly trained technical workforce. So all of the elements are here for the space industry, and we just need to make it happen. So I'm glad to see you all here and your interest. So let me ask you a question. How many of you are here for the first time? Wow. Okay, that's great. I see a number of you are students. You were sent here by your professor. Is that correct? No, that's great. I really appreciate you guys coming out, and I hope you find the program this evening interesting. I have to give a shout out to our sponsors, MHub, which is this lovely space that we find ourselves in. MHub is a manufacturing innovation center and startup incubator focused on developing manufacturing startups. And we're very happy to have their support, and they let us use the space. Our other sponsor is Metropolitan Brewing. They are one of the first craft breweries in Chicago. They've been in operation for over 10 years now. And so I hope you've been appreciating their delicious beer. One other announcement, if you have not found the restrooms, they're back that way, just this side of the big mural by the massive sliding door. So NewSpace Chicago, like I said, supports NewSpace, which is basically entrepreneurial space companies. And we occasionally cross-promote other events that are happening in Chicago. So CFA Chicago is the Certified Financial Analyst Society located in Chicago. And this Thursday, they're having an event called Investing in the New Space Race. So this is going to be an investigation of what are the opportunities in the new space industry and what the opportunities might be for investing in those companies. The panelists for this event actually are a number of luminaries, some of whom have presented to NewSpace Chicago before. They're listed up here. Rich Godwin is an amazing speaker. He is president of Space Technology Holdings and also involved in Space Bridge Ventures, which is a space VC company. Joan Johnson-Fries, I don't know her, but she's involved in national security affairs at the Naval War College. Steve Jorgensen has also presented at NewSpace Chicago. He is also involved in Starbridge Ventures and has an amazing knowledge of the new space industry. Mark LaPena is CEO of a company called Synesis. They do optical communications technologies for satellites. They are a local Chicago area company, so he actually is another new space entrepreneur in our area. And Miles Walton, unfortunately, I don't know him either, but he is apparently a senior analyst at UBS in the space and defense area. So I'm expecting this will be a very interesting event, and I would suggest that it's worth going to see. It will be this Thursday at the Palmer House Hilton. And if you call the number listed here and tell them that you're with NewSpace Chicago, they'll give you the member rate, which is $45. So I'm looking forward to this, and I think there will be some interesting things there. So, have you guys heard about the Chandrayaan-2 mission to the moon? Whose hands? You guys have heard of it? Okay, great. So, I like to give a little update on things that are happening in the space industry. Chandrayaan-2 was launched July 22nd, and this is a mission from India. So I'm very happy to see more countries being involved in space, and the India Space Research Organization has done a number of amazing missions. Most notably, several years ago, they sent a probe to Mars for something on the order of $80 million. Tremendously cheap. Anyway, Chandrayaan-2 was intended to go to the moon, and there would be a lander called the Vikram lander, which attempted to land a couple of days ago. Very exciting to see the 4th country in the world to actually send a lander to the moon. Unfortunately, we're not quite sure what happened. It did not have a successful landing. We believe it somehow ended up on its side. They lost contact with it shortly before it was before it was expected to land on the ground. But nonetheless, this is indicative of the kinds of things that are happening in the space industry today, with all kinds of organizations being able to go into space, do useful things in space, and even go to places like the moon. We're going to see a lot more of this coming in the very near future. So at this point, I would like to put out a pitch for an activity that we call lightning pitches. These are an opportunity for you to stand up here and talk to the rest of you. If you have a space-related idea that you would like to get feedback on, maybe to get the attention of investors, maybe, but mostly to just try out the idea and get some experience pitching the idea, the lightning pitches are your opportunity. You get 3 minutes to pitch an idea and then 3 minutes of Q&A after that. Unfortunately, we don't have any tonight, but we are expecting to have at least one next month. And if you have an idea you'd like to try out on our group here, please contact me or one of our other NewSpace Chicago people, and we'd be happy to give you the opportunity to take the stage for a few minutes. So this evening we have Alex Smith from Stofiel Aerospace to talk to us about 3D printed rockets going to orbit, launching small satellites to orbit using a 3D printed rocket. It turns out that there are a lot of companies who are trying to build launch systems. I just got back from the Small Satellite Conference last month, and there are over 100 different companies in this space that are trying to find an affordable way to put payloads into space. You might have heard over the summer, one of the big high flyers called Vector they basically ceased operations. It's still not entirely clear exactly what happened because they had just taken some funding from the Air Force and also from investors, but then they had to stop operations. Anyway, the point is that this is a crowded space. There are a lot of contenders, and we're going to run into problems because, as you might have heard, space is hard. Stofiel Aerospace has an interesting take on this, and I'm really excited to see them succeed because I think they have some really good technology, and it's a great opportunity. So Alex Smith is the CEO, COO, Chief Operating Officer for Stofiel, and without further ado, let me turn it over to Alex.
Okay, so I'm Alex Smith. I'm the Chief Operating Officer for Stofiel Aerospace. We 3D print plastic rockets for low Earth orbit, and it's about as crazy as it sounds. The rockets, the plastic is treated. It's not entirely plastic it's plastic when it launches. It's not plastic after it fires. We've got BOREAS. It's a three-part system here. It's a balloon. It's a plastic entirely solid fuel rocket. In fact, it's the first solid fuel rocket to be able to thrust, throttle, and vector. We can change its speed and its is different. We're 100% mobile. We print the rockets to the mass that they look, so they're all bespoke rockets. Our in-house unofficial motto is, you bring me a payload on Monday, I'll have you in space by Friday. The caveat being State Department.
Thank you. Okay. Wow, I'm a lot louder than I thought. We do dedicated launches on demand. These rockets, since they're solid fuel, they're able to sit in a shipping container for 10 years. Currently, with the liquid fuel rocket, it's about 48 hours for Elon to fill one of those rockets, and he's got a small window in which he can launch that rocket before he has to drain the fuel from it. They're highly volatile. They require massive amounts of infrastructure and human capital in order to get off the ground. Typically, I think last time we were here, we did a full breakdown of the technology. We're gonna dance around that a little bit, and then after I'm done, we can talk more about the intense nerdery that goes on down in St. Louis. So, first I want to talk about the market. Vector going under recently is a big shock to a lot of people. We all know that there's over 100 people, 100 companies in this space operating. They're not all created equally. A lot of them are very well-financed websites, but Vector had the goods. They had a modified Russian missile that they were using. They were very well-financed. I think their last round, total fundraising of, I think it was 100 million. I think the last bit of that was from Sequoia. But there's other groups, the Strata Launcher, X-Core, Aphelion. A lot of these people who, I think at least the VC world believe that, we're going to pan out, just aren't panning out. And there are some reasons behind that, and I think we can suss some of that out tonight. Am I still too quiet, or is this okay for everybody? All right, so this slide isn't exactly an alternative market view. I think we all agree that space currently is a $350 billion ecosystem. It's a lot of the same old names that you've seen a lot. They're all hanging out, talking to each other. It's one big happy bubble. Everybody's very excited. Nobody's going anywhere. It's supposed to grow to 2.7 trillion over the next 3 decades. At least that's what Merrill Lynch would like you to believe. And we think that's true as well. But that growth is going to come outside of the traditional supply chain for space. It's going to come from the pharmaceutical companies, the biotech companies. Even more Earth observation as sensor development continues to go on track. I think the big question here is, if we go back to that other slide, one common word in all of these articles for every single space company that goes under, there's one word that is threaded through every single one of them, and that is revenue, 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 okay? None of them have any revenue because they're all building for a launch market that doesn't quite exist yet. But the question here is why haven't the pharmaceutical or biotechnology companies entered the marketplace? Now, if you listen to the experts, by the way, I'm not here to make friends tonight. If you listen to the experts, they're going to tell you it's cost. Cost, we've got to get the cost per kilogram down. Cost is important. It's not enough, though. If you look at the pharmaceutical companies, this is the R&D budgets for the top 5 pharmaceutical companies. I don't think any of them are hurting for money. I mean, they're all within, a couple of billion of each other, hovering around 10 billion, a few billion here, a few billion there, before we add it up and it starts looking like real money. And, if you're telling me these guys can't afford to do exoscience, then I'm going to call you a liar. You're absolutely delusional. For us, it's not a matter of cost. It's what we're looking at as a capabilities deficit. The pharmaceutical and biotechnology companies in particular want to be able to do repeatable experiments. Okay? And repeatability is the foundation for good science. They were promised the moon with the Challenger in the 80s, and it never materialized. Repeatable launches never materialized for them. So they felt burned by that situation, and they've been reluctant to sort of get into the fray since. But I'm telling you right now that dropping it down to whatever price per kilogram isn't going to affect their entrance into the market. It's a mismatch of business cycles. Us in the space industry are used to measuring things in years. Their business cycle is much shorter than that. I mean, can you imagine being a middle manager at Pfizer and pitching to your boss, hey, I've got this great idea for some exoscience. It's going to cost you $5 million, and the ROI will be available in 7 years. Neither one of them are going to be there in 7 years. There's no personal motivation to actually do that. Nobody's going to take the risk. It's not going to happen. when we started this company, we did a lot of market research, talked to a lot of companies out there that were once thinking about going into space and haven't gone yet. And then there's a series of capabilities that they require. And some of those capabilities are really the on-demand access is a key one. These guys want to run 2 to 4 missions a month. And they want their science experiment back at the end of it. Today, if you wanted to put something up and bring it back down to low Earth orbit, which is a huge space, the only thing that matters is a 300-yard wide corridor called the International Space Station with small doors on it. Everything in space that you want to bring back down has got to travel through. And if it returns on the Dragon capsule, which is the current setup, you're experiencing between 4 and 9 Gs. So if you're a Pfizer and you're doing drug crystal growth in 0 G, you're getting back a box of dust. Okay, that's what you're getting. We have the ability with our Hyperion return system to do what they call atmospheric skipping. This has already been tested out through DARPA. We've flown it with DARPA, and it works. So we can bring you back in under 1 G. And we can also land in a local municipal airport. So I'm talking about bringing an experiment that is in 0 G back to terra firma within 10 minutes to your door. And I can frankly land the thing on skids if you have a big enough field. So I mean, it's about door-to-door delivery. You're not fishing something out of the Pacific Ocean. You're not getting back a box of dust. You're getting your intellectual property back, your data back. And I think that'll drive a lot more scientific discovery. The launch teams, the no infrastructure part of the launch side of things is a mass-up equation, as we like to say. Because it's a solid fuel rocket, it is stable. It's incendiary, not explosive, so it can sit. It's actually designed to be launched out of a shipping container. It was designed for 4 privates. I don't know if you've met any privates. 4 privates in the military to be able to launch. So it's a very simple system. Maybe 4 privates in a bus sergeant. Somebody's gonna be in charge. So, the on-demand access, and if we know the mass of your payload, I can pre-print, dozens of these things, just send them off the production line and have them waiting for you in strategic locations. We can launch this thing. Because it's a balloon-based launch, I don't have the same kinds of problems that a liquid fuel engine would have as far as launch goes. I don't need the environmental controls. I don't need the massive amounts of infrastructure and people in place in order to launch it. So it gives us it allows us to be pretty nimble. As I said, this design process was, the reason we have a balloon and a solid fuel rocket, and a funny wing thing. It's not an accident. We are really crazy. We're not that crazy. This is on purpose. This design is based on what we believe that the market was asking for. So it's 100% on purpose, and it allows us to create these different flight profiles. The ability to operate standard fairing if you're just dropping off a Earth observation satellite. The ability to launch a science experiment, provide environmental and power controls, and return that experiment to your door. In under 1 G. I think those are the things that people are looking for right now. And as if I didn't make enough friends bad-mouthing the competition and telling you that they're dumb, this slide is definitely not like, are there any VCs in the audience? Fundraising is not a business plan, okay? And I'm going to say that one more time because it bears repeating. Fundraising is not a business plan. The only people that we're really competing with at this point is Rocket Labs. Now, Rocket Labs, they're the ones, they're actually doing the do. They've got the goods, they're sending things to space, and we're very happy for them. But they didn't get there until they raised $150 million on the back of the Series E. E, not C or D, I didn't start, E. And every time I hear about Series E, all I can think about is the poor son of a gun at position A, who took all the risk and is now sitting, with a significantly diluted position. We're not interested in playing that game. We're not interested in flipping equity on the backs of the innovators in our company and the rest of the market. We're not that interested in that. The question is how are we going to fund this rocket? Now, mind you, right now, Rocket Lab is $150 million. For me, I need about $2 million in a building to get to Carbon Line. So, we're the value buy, as it were. We're the JetBlue. The intellectual property, that's how we're going to get from point A to point B. The ceramic process for the rocket, When the rocket fires, it acts as a kiln, turns the plastic into a ceramic, a new composite ceramic that has a lot of different applications across different verticals. Brian Stofiel, my partner, Brian Stofiel, he is an avid biker, and one of the first things we started coming out with were exhaust systems for motorcycles that are cool to the touch, highly customizable, which is sort of that market anyways, and absolutely cool to the touch. We also have Hephaestus, the heat coating, which is, we can apply that to metal structures that exist right now. So think HVAC or rally cars, race cars, exhaust systems on race cars. Those exhausts, they run about $20,000 a piece, and they burn through one of them every year. If we can extend the life for one extra season, it's worth it to them. So we've got the heat coating, and then we've got the 3D printing, combined with the heat coating, which is the positive structural molding. So those are the two pieces of intellectual property we're working with today. We've got several others in the pipeline, but monetizing those are exactly how we're going to get from point A to point B. Some of the this is actually a picture of an early heat shield or an exhaust system on a motorcycle. Just to show off the ability to customize the entire exhaust system. Also, when you put this on the bike, again, it's cool to touch. I don't know if you know anybody that rides a motorcycle, but most likely they've probably got a nice little scar inside their leg. Most of them do. Those exhausts get pretty hot, and this sort of solves for that problem. The ceramic is good for environments where we have temperature considerations, where weight is a factor. If you look at the exhaust systems on your typical city-to-city plane. I flew in today from St. Louis, and that jet that I rode is about 350,000 flights a week on jets that size. Each one of them have 2 exhausts. Each exhaust weighs about 150 pounds. I can print that down to about 10 pounds a piece. I have just taken a fat guy like me off of every leg of Midwestern flights in the country. In fuel costs alone, that's a significant savings. The durability, the rocket currently holds to, by the way, this plastic, just to give you an idea of what's happening here, this plastic is the stuff you get from Micro Center. It's PLA, it's cornstarch-based plastic. It melts at about 200 degrees Celsius through the extruder as it's printing. Right now, our plastic, our rockets are holding it upwards of 3,000 degrees and 10,000 PSI. So there's an extreme amount of durability, heat resistance, and the customization. That's really important for us, especially on the intellectual property side, because there are a lot of markets that are served. Right now, if you look at the automotive market, it's all about custom this, custom that. And same thing with motorcycles and a lot of others. I'm just going to run through a handful of the industry applications. The combustion engine, we've got automotive, motorcycle, aviation, agriculture. There's y'all are from Illinois. You've seen it. You've driven down south. You've seen the farmland. There's a lot of that out there. Energy production, petrochemical, drilling bits for oil exploration. That's something that we would use actually just the heat coating on. And it would protect the metal on the drill bit. It creates a bit of a super fluid underneath the drill bit and extends the life of a very, very expensive piece of equipment. Nuclear. You probably think I'm nuts, but we're actually in the middle of conversations right now with a company that will yet to be named. And they do miniaturized, hardened, ruggedized nuclear facilities, miniaturized, I think microgrid applications. And we're in talks with them, and we're going to be doing some research, sending some samples out to Oak Ridge National Laboratory, and you'll be able to read about it in an upcoming journal article here in the next several months. So, there's a lot of opportunities in the energy production side. Circuit board production, again, the heat coating, not the molding process. When you're soldering boards, this is something that we can put onto the board to protect the plastic that exists, and reduce loss and failures of the board as during production runs. HVAC, again, the temperature issues, we can coat existing metal pipe, or we can come in and print piping for you. That holds the temperature and it has a higher thermal value. The die cast for form molds and injection molding, all those things are made out of metal currently. And if you have to CNC lathe it, if anybody here has had to send anything out to be CNC lathe, you know that it's extremely expensive and there's a huge time lag. And if you've made a mistake, let's hope you've done it out of metal and not aluminum. Because then you're going to need to sort of solder things back into place, weld things back into place. it's not very customizable after you've invested that initial capital. So the design process is almost twice as important as the actual production of the mold. We're able to actually, you can run the mold. It would be cheaper to run the mold with us, and then any design flaws that come up, you can reprint and do another one. So that it changes the design process for some of these verticals. And plastic manufacturers, we want to pass those around a little bit. So I've got a couple of pieces here. One's a heat shield, an actual heat shield for the motorcycle. The other one's a new little product that we've sort of been playing around with, and it's actually a ceramic chainmail. Think of it. Being able to conform to different kinds of shapes and sizes, giving it durability and a bit of a temperature protection as well. And that's something. Those have both been turned into ceramic, and you can imagine what that would weigh if it were metal. And you can see the significant weight savings there. So our current rollout right now, I mentioned some of this stuff. We were just in Sturgis a couple weeks ago. I don't ride a bike, so that was very interesting for me. But we, there is a huge, for us, there's a huge cultural play here. Motorcycles and aviation have a long history together. Glenn Curtis building a V8 motorcycle, affectionately dubbed as Hell Rider, in the back of his bicycle shop. At the same time, he's having patent wars with the Wright brothers in the back of their bicycle shop. Glenn Curtis was actually the first person to get their commercial flight license. Aviation, the birth of the combustion engine, aviation and motorcycles sort of go hand in hand. In fact, the Messerschmitt, the old Messerschmitt, one of the original Messerschmitts has a motorcycle engine in it, basically. So, this technology on the ground brought us to the air, and our whole play is to bring the technology back to the ground. In the motorcycle, automotive, nuclear, and aviation, those are our current rollouts right now. So with that being said, I'm going to cut myself off and open up questions by asking all of you a question. What will you do in space? At the end of the day, bringing in the pharmaceutical companies, that's step one. What we're really excited about is the opening of human capital. When the guy down the street working in his garage, tinkering on something new, has access to low Earth orbit to test it out, what kind of ideas are we missing out there right now? We're probably missing a lot, because you and I are no closer to having that access than we were, 60 years ago. So that's all I've got to say, ladies and gentlemen. Any questions? Bueller, yes.
How thick is the ceramic coating?
So the ceramic coating is actually pretty thin. We're talking about, well, listen, there's a couple parts to this answer. One is the heat coating itself. So treating metal, it is a very thin coat. The plastic molding requires us to dope the plastic in a special way with certain materials. But when we print, we're not printing a solid piece. We want space. So the fill is it's important to have that fill in there that maintains structural integrity of the two walls of the rocket. But we don't want it too thick because we want this material to be able to pass in and out of it and really fill up those gaps. So that way, after we're done with the doping process, we add the heat coating to it, and then it gets fired in the rocket. Or as with the other process, we're using a kiln to mimic the rocket firing. So it's very thin, very thin. So the other thing is that this ceramic has a little bit of give to it. We haven't been able to look at it under the electron microscope, so we don't know if polymers are being sort of encapsulated or if it's the other way around. They're forming the structure and then everything else is ceramic. We don't know exactly how it's working. We just know that it works, and it's a lot like our rocket. Well, it's true. It's true because you know what? I can't run my rocket through a CFD. So a flow dynamic model. I can't run it. Everybody else in the industry is able to build a rocket online on their computer and run it through a model and see if it works. My flow dynamic uses a different physics, so I'm not able to actually. The math doesn't exist for the rocket yet. But all of the experts that have taken a look at our data, our hard data, and that includes George Alexander, who's an exotic propulsion expert, which is probably one of the coolest job titles out there. Exotic propulsion expert at NASA Glenn, St. Louis University's Park School of Engineering, Mac's old team, and a whole slew of other professionals have looked at the data, and it's doing exactly what we said it was going to do. Now, we don't know the math behind we'll hire people for that. In fact, SLU is actually working on sussing out our data sets right now and helping us build a model that would be usable for us to show others. So that's something that we're currently working on.
So you guys presented to NewSpace Chicago last year, and we had the privilege of being witness to a test firing of their rocket motor in the parking lot of them, which was very exciting. And there is video of it on our website, so I encourage you to check that out. But my question for you is, in the intervening time, could you speak to the progress that you've made since then, and what opportunities you've come across?
Yeah, so sure. I think for us, when last time we were here, we were wrapping up. We're getting ready to finish up a series of bench tests. Basically static fires in the rocket engine. We've done almost 40 to date. When we left here last time, we began to do what they call hover testing. So I'm able. This rocket is a typical stick rocket. Think of a firework. If you light a bottle rocket and send it loose, it goes all over the place. And I remember as a kid doing that with my buddies at the back end of a plastic bat, and the things just go flying, and you might get hit, you might not. Well, this rocket operates differently because of the flow dynamic. I'm able to hover. If I put this thing on a direction, it will fly straight. Now, no other solid-fueled stick rocket is able to do that in the world. It does not exist, except for in this case. So the hover testing was a big thing for us, sort of showing that yes, this is doing, the flow dynamic is doing exactly what it's supposed to be doing, maintaining its vector. Whatever vector you put that rocket on, it will maintain without fins or guidance or any of that. It's just the flow. So we got through that, and really since then it's been a mad rush to start pushing out the intellectual property. The IP is really for us a bigger market than the launch market will be when it's grown even. You look at how many guys do you know that work in their garage on a custom car, and would love to have a custom part for that car. So, it's aftermarket parts too. We're currently printing out thermostat housings for the old Dodge Viper, which is kind of fun. By the way, I knew nothing about cars when I started working here. I've learned quite a bit. The market is big, so for us, really shoring up the IP is really for us the way to go, as opposed to, because I can't tell you how many times I've sat with VCs, well-meaning people. Some of them do bring value to the table. Don't let them kid you. Some of them do. But at the end of the day, how many times am I going to let you kick the tires? I got work to do. And for us, it's all about building on that intellectual property. So we've been looking at those markets, identifying opportunities. And actually this week we'll be signing some of our first contracts with some of the race car companies that are local to us in the Ohio area to integrate the ceramics into their build-out process. And it's everything from valve covers to air intakes, to exhaust systems to body kits. So we're able to do quite a bit of things. And really for us it's great because when groups like that come to us and start operating, they're the ones coming up. We give them access to the technology, and they're the ones who come up with the great ideas for it. So we sort of open source that aspect of it. But you'll be seeing it. It'll be raced this next season. There's a car that'll be doing about 100 rally races across the country, and they'll be running with Stofiel. Hopefully, a nice Stofiel sticker somewhere in there, on the car. So.
So, how do you throttle and thrust?
Say again?
How do you throttle and vector thrust?
How do we throttle vector and thrust, throttle vector?
Yeah, so it sounds quite uncommon for solid motor.
Well, not only is it's not just uncommon, it's unheard of. It doesn't exist, except for in this case. I can't go into too much detail on how we do it without signing an NDA.
Yeah, I suppose it's not a cable system, something different.
Well, listen, at the end of the day, we have a rocket engine that's just designed differently than other rocket engines. The entire engine is one print out of plastic. And I don't think a lot of other engines have that. You've got Relativity Space out there that is doing some 3D printing. They're taking 100,000 parts, printing is brought them down to 10,000 parts, and a robot's going to put it together. And it's all metal. And it's still liquid fuel at the end of the day. the solid fuel, the issue with the solid fuel has always been, that it is like a bottle work, it is like a firework where you light it, it's a chemical reaction, and it has to move, and it has to keep burning. We have a way to track that and move and shift that flow, and that allows us to change. I can reduce speed by something like 20% and only lose something like 10% of power.
Do you mean you can alter combustion rate?
What's that?
Do you mean you can alter combustion rate?
I don't have to alter the combustion rate. So, and that's where I'm going to leave that question before I get in trouble.
So you also talked about how you're applying, sort of like you're bringing your technology to other industries.
Yeah.
So it sounds like, do you look at the like industrial coatings industry too as a way to sort of, break in for part of your business model that might, lead to additional funds for sort of like the space exploration part of it?
Yeah, absolutely. That's something that we've, listened. I mean, there's different materials out there like aerogels and things like that, and coatings as well that exist. For us, I'm not interested in entering a market space where I'm in direct competition with somebody. I'd rather go to the automotive industry, and because nobody has the ability to print something on the fly to spec, and turn it into a ceramic. And so really we're looking for right now. I think at this point in time, we're looking for the makers, the other makers out there, the tinkerers, the people who have wild imaginations and see the potential of the technology and want to run with it in a certain direction. And we want to give them full ability to run with it. Down the road here, all these these are short-term sales for us. They're one-year contracts. And the idea is that over the course of the next few months, we'll be drawing the lines as far as the industry verticals and applications that people can use the technology for, and go into individual groups and licensing, actual licensing of the intellectual property. There'll be exclusions, for instance, obviously aerospace, you're not touching that. And the motorcycle industry, frankly, because that's something that's near and dear to us. The motorcycle industry and the automotive we're willing to do an IP license on, but everything else we want to, the motorcycles and the aerospace we want to hold on to for ourselves. But these are short-term contracts. It's just designed to float us through to the next stage. But yeah, I mean that would be somewhere that we have looked different kinds of coatings that exist out there. I just think that it's a long road to hoe. It's too much work for me because we have limited resources and we have to be smart about how we execute. And for me, it's just a matter of there's too many people in that space, especially in the coding space. Because there's a lot of stuff that exists. So how do you differentiate yourself? Well, nobody cares that it comes from a rocket. I mean, it might get you to the meeting, but it's not going to get you to sale. Whereas the other guys, they see the full spread of technology, they can put it to use immediately, and they're also going to be feeding us with new and novel ways to apply the technology, which I think is the most, again, human capital guy. That's the most exciting part of the thing is what other people need to do with it. So,
Thanks.
Other questions? You guys must have questions.
What would you say would be the best piece of advice you could give to an engineer about starting an aerospace business or participating in the startup of aerospace?
yeah, don't count on revenue from launch. That's just a bad way to go. As we've seen from the earlier slide. I mean, I think, listen, it's hard being, I think, an aerospace engineer because you see all these companies folding and, there are a lot of great, hardworking people out there that are brilliant in their field that are getting shuffled around. And that's going to be the nature of it for a while. So, I mean, I think building a skill set outside of engineering to make yourself valuable to teams that need to work across disciplines, across geographies, being able to communicate with social sciences people as well as fellow engineers is a huge skill set. And I think that's one that's going to differentiate you from the rest of the crowd moving forward.
So if you're deriving revenue from like these one-year contracts and licensing and everything, there must be incentive within your organization to kind of like shift the focus in that direction. So how as a COO, do you keep the focus on rocketry launch?
Yeah, no, well, we've, listen, again, limited resources. We've had to sort of put some things down. We haven't done a bench test in a few months here. And that's okay for us. We're at a developmental stage where the next series of tests that we do are simply designed to increase our ISP. And we know how we're going to be able to do that, increase our efficiency and our burn rates that way, because this is the last set of tests before we go to Carmen. And Carmen being the line in space where space begins. That's the big benchmark for all the launch companies, and we're right there. I mean, we're going to make the last few tweaks. So shifting between the two, I mean, it's. I mean, you do twice the work. I mean, I don't know about 8-hour days. I've never heard such a thing, but it's worth it to us to make that shift internally and make this the focus. Because at the end of the day, really at the end of the day, this is worth more money than the rocket is. And the rocket, that's something we want to do personally. We all want to do it in the market. There's a need, there's a demand for it in the marketplace. But we can't get there unless we walk through this first. And for us, this is the path out. We have to go through the intellectual property in order to get to launch. So it does take some shifting, but I think we've got a good team, and everybody's sort of stepped up to the plate. And at the end of the day, you're selling widgets, whether it's a rocket or a heat shielding. It doesn't mean you're selling something. So it's just shifting perspective a little bit, and it's part of our story. And it's part of who we are. So any other questions?
So everybody focuses on your rocket engine with the ceramic composite for the nozzles and so forth, but your payload return vehicle is very interesting also. Can you say a little more about that and how far along you are with that?
Yeah, so Hyperion is a wing. We don't like to call it a drone because we have to go through certain offices, so it's a wing. Hyperion has been a lot of fun. It was actually based on, we've got a company that we've been working with, very good friends with, WetSpark. It was the name of one that they just recently started a new group. But this wing has been flown with DARPA, so the wing has data on it. We know how it operates. It was designed originally to be just a very high altitude, 70,000 foot drone. And then we started playing with WetSpark, playing around with the re-entry capabilities on such a device. And we're able to make different sizes of Hyperion. So if we can send out swarms, we can do a simple one vehicle launch. But the key to Hyperion is the atmospheric skipping and the ability to return to terra firma without experiencing more than 1 G-force. It also, like I said, provides power and environmental controls for any science experiments on board. But the return is really the key. And as I mentioned earlier, the return to a local municipal airfield, not being dumped in the Pacific Ocean. It's something that, as it comes through, as it slows down from skipping across the atmosphere, it's still orbiting as it skips. It slows down and then it does a dive through the air column. As it dives through the air column, it gets to about 15,000 feet, levels out, and lands. So I mean, that's something that doesn't exist with any of the other return vehicles that are out there. They're all capsules on parachutes, and you're fishing it out of the ocean. I don't think anybody has time for that. I don't think Pfizer has time to fish something out of the ocean. So, for us, being able to land it is a key thing. It also doubles as a, actually, there's a. Let me go back here, because this little picture here. So you see this isn't exactly what's on the website. In fact, this picture isn't out there a whole lot. This is Hyperion designed for space travel while in space. So the idea is, these are actually the Hermes rockets, and they're solid fuel again. If we brought a handful of them up to a Lagrange point, we can leave them be. You get up there with, you've got Hyperion. It's lock and load propulsion. You're ready. You simply just set it in there. It's like your flight computer, and it'll burn at that rate and those vectors. So the Hyperion is something you're going to be hearing a lot more about next year, because we'll be in a position we'll have our first launchable Hyperion hopefully in about a year. But the ability to lock and load propulsion, I think, is really the key thing here for the Hyperion. Being able to stash propellant at the Lagrange point, the propellant being, safe, not reactive, just sitting still, being able to lock it into place and then take off from there. So Hyperion has a lot more behind it than just a re-entry vehicle or just, it's also, also early on, we'll be using Hyperion. It's where our flight computer is stored. It's why the rocket is able to be disposable and cheap, because our flight computer isn't part of the rocket itself. The rocket itself is fairly dumb, but Hyperion houses the flight computer and is able to calculate, instead of typical launches are from point A on the ground to point B in orbit. Hyperion, since you're going up in a balloon, it needs to calculate X to B. So we have a flight computer that calculates on the fly its position in space without using GPS, and then it sends the firing solution to the rocket and sends it on its way. So it's our workhorse. It's something that, as I said, we've got the data showing that it works. It's just a matter of funding. So I better get to selling some motorcycle parts. Any other questions? Sorry, I'm sweating up here. It's the lights, it's the fame. Go ahead.
Hi. So what have you guys tested in terms of permeability of your material with radiation? So like medical experiments?
Sure. Yeah, absolutely. So that's actually what we're getting ready to do with the company that shall not be named. We're actually going to have samples. They have some specs for us. We're printing out some samples for them to send off to Oak Ridge National Laboratory. I don't have access to electrons. I'm pretty sure if I did, the government might come knocking and have a word with me. So we want to be able to get some good data on that as it relates to the nuclear industry. Because there are a lot of, as you mentioned, medical applications for this material. Because nuclear medicine is a thing. So getting that data though is really the first step. Currently I'd rather have somebody else pay for it than pay for it myself. So I'm okay with them doing it. So.
What's your other background?
What's your other background? How did you get involved into where you are today?
That's a great question. I actually tried to answer this question earlier, and I've been in startups for a few years now. 6 or 7 years. I was in the service for a while. I did air and missile defense. I trained to work at BOREAS. I ended up as a paratrooper in a second, so I did a lot of SHORAD for Ranger Defense. But I'm a social sciences guy. I'm not an engineer. I'm the guy that translates what the engineers do and explains it to everybody else. I'm science literate, barely. So my background is the things that I bring to the table is I know how to build a team, and I know how to manage up, manage down, manage side with that. I'm good at that kind of thing. So I do a lot of the business side of stuff and the human capital side. So I think organizations that are entirely comprised of engineers have a hard time communicating what the heck they're doing. There's a lot of brilliant people there, but you need somebody to be able to explain what is going on and why it's important or why it's not important. So that's sort of my role with the organization is to chief translator, house mom, a little bit of everything.
So, it's related to 3D printing, additive manufacturing. I know part of the issue with kind of the onset of aerospace applications for 3D printing is just that the resolution or the quality of the prints aren't quite there. I guess, do you, as your technology and to the rocket side, need to see advancements in the quality of 3D printing, or is it kind of ready to go now?
So when we first started doing this, we were printing our first rockets on a $150 printer because we can, and that's the only reason we were doing it, is to show people that the barrier to entry with 3D printing is so much lower. And currently, we just splurged recently after a small fundraising round and bought ourselves a $1,000 printer, which is, I know, it's a lot of money. Hey, for a guy who eats ramen for dinner, that is a lot of money, okay? So, but there are printers out there that, I mean, you can spend up to $500,000 on printer, depending on what you want to do with it. For us, that level of print, it's not required. It's not necessary to get the job done. We're more practical than anything else. I mean, if we had, if we were worried about, maybe we were doing silicone chip production and we needed a clean pipe that was smooth on the inside, that could, a certain flow rate of gas or whatever it was going through, then, we might have problems and might have to adjust. But for our applications, all of our applications, the print quality that we have currently is more than sufficient to be put into play. And like I said, we started with a very inexpensive printer that wasn't a very good quality print, but it worked. And I think that sort of goes to show you that 3D printing and that kind of manufacturing, it is going to lower the barrier to entry as time goes on. It won't just be nation states and billionaires playing the game. It'll be guys like me. So. Anybody? Any more questions?
So earlier you expressed some interest in like ideas that the average Joe might be using this for. What are the best ideas that you've heard of so far for practical uses outside of the major ones?
That's a good question. I think some of these automotive guys are fascinating. I mean, just the valve cover example, and that's a situation where heat and really durability aren't really the thing. It's about being able to customize the valve cover, raise it up so that the piston gets a longer stroke. I mean, little things like that. It's never the blow your socks out of the water kind of application that is most revealing about the capabilities of the technology. It's always the simple little things that you're like, I wouldn't have even thought of that. I mean, so things like that have popped up. I think the temperature housing for the Dodge Viper was a lot of fun to sort of work on, because you hear about these cars, apparently like 60% of them were back in the shop within the first few months, and that's because it's a V10 engine and you will kill yourself in that thing coming off the line. They come off the line and swerve and the back ends are destroyed. So aftermarket parts, all that kind of stuff is interesting, but I think these guys are doing new things with the technology. The guys that we're talking to now, the rally car that's going to be out in play this next year, we're talking about putting infill inside of an engine block, an existing engine block, to increase stabilization of the drive shaft and all that. So I mean, things like that are really, I wouldn't have thought of off the bat. These guys really, what I look for in a customer, I mean, besides a check, is the ability to really, I want to see some fire in their eyes. I mean, those are the guys I get excited about, because they're the ones who are sitting there thinking about all the different things they can do with this, and they're going to do it, and they're going to break a lot of stuff in the process. And I'm really excited for them to break stuff, because that's when you start learning about the limits of the technology, and you really get a good feel for what it's capable of. So that's the exciting part for me.
That leads into my question.
Sure.
What kind of customers have you been partnering with on payload considerations, and what kind of payloads and testing and stuff?
Yeah, so right now we've only been doing static fires, so ground-based fires. So we're not. Listen, there's a lot of these companies that are out there that are wanting to take a check at this point in time. They haven't even hit carbon line, and I'm old school. I think that's totally dishonest and disingenuous. It's just a crappy way to do business. I'll take your check when I show you that I can hit carbon line. And as far as payload goes, we're agnostic to payload. We don't care about payload. We are literally just the ride. I mean, I don't even want to do a lot of integrated payload. I just I want to be able to snap it into place and be done with it. This is a mass market. We have the capability of doing 1,000 launches a year, the first year of operation. So I can't outlift a guy like Elon Musk. I can outfire him now, which counts for something, especially when you look at the size of satellites and how they're shrinking, and sort of where those numbers are falling. There seems to be two poles. The 6 kilogram marker, which is where all those doves and constellations are. And then there's about 200 to 300 kilograms. It seems to be a sweet spot as well, where things sort of coalesce and there's a convergence of weight class there. So for us, those are the two areas that we're really looking at within the small satellite launch market. Those two sort of weight classes. But as far as payload goes, we don't really care. That's your business, pal. In State Department, right?
Can you just give more details about how you're going to control the heading of your rocket during the ascent? Because I guess you talked about...
Say it again?
Can you just give us some more details about how you're going to control the heading during the ascent, please?
Control the heading?
Yep.
Of the rocket?
Yep.
The vectoring of the rocket? Yeah. I got really close to getting in trouble last time I tried to answer that question, but we're able to use a series of baffles and things like that that change the directional flow. On the back of the rocket, let's see if I got a picture of here. So this little stick coming out right here, this is, typically you would see this on a rocket that has to travel through the atmosphere. Mind you, this thing is launching at 100,000 feet. So at 100,000 feet, my fuel is reduced by 70%, my structural engineering by 30%. I'm not fighting the air column. Usually that's a full spike. They call it an aerospike. Dr. Davidian is sort of the expert on aerospikes. We brought this down to him and he says, it's not an aerospike. A good significant amount of our thrust comes out of that hole right there. And any vectoring comes along the edges of the rocket. So I can tell you that much. But it's not it looks like an aerospike, but it doesn't act like an aerospike. As I said, the vectoring comes, along the margins of the edge there. So, baffles. That's as much as I can say. Oh, thank God, I hate these awkward silences.
I don't know that you'll be able to say or not, but when you land, how much percent of the fuel do you still have?
None.
None?
None. So this rocket, the rocket is separate from the landing vehicle. And the landing vehicle isn't using any propellant to get back down to the ground. It's using good old-fashioned gravity. For us, the rocket basically disintegrates upon re-entry. So there's nothing left of it as it returns.
How much fuel did you not use?
Okay, so this is a question about ISP number. So ISP measures the efficiency. We are currently approaching today, without doing our tweaks that are coming up in our next round of testing. Today we are approaching the low threshold of liquid engines. So we have extremely high ISP rates for a solid fuel rocket. Extremely high, like unheard of, just like, you don't have to believe me, you'll see it eventually. But the burn rate is extremely efficient. And that is in a large part due to the flow dynamic. And it really, it forces the burn. So. Say again.
What does happen with the fuel additional burn?
Well, the additional fuel? Well, they're usually, these rockets are printed to the size of the payload. So we aren't a mass lift system. So currently, if you are, say, Rocket Labs, I gotta stop saying vector because they're going, so I'll use pick on them for a while. So if you're Rocket Labs, you have to fill the tank, and then you sell seats on the bus, as it were. So Elon even, he's got a main payload, and you're buying secondary payload space, like a bus ticket, and if he doesn't sell all the seats, his margins go down. If he sells all of them, great. For us, I don't have to worry about that. I print it to the size the rocket is for you, and whatever weight of the thing is that you're putting up into space. So, it's extremely efficient. It's extremely efficient use of resources, especially when it comes to propellant. Propellant can be expensive if you're not mixing it yourself. So, for us, it's it makes sense to have a bespoke rocket as opposed to a standard rocket that you have to fit payloads onto. This one is printed for the size of yours. So.
We have time for one more question. What altitudes are you predicting to achieve, like low Earth orbit?
Yeah, launching from 100,000 feet, our first carbon line launches will break 350. By far, they'll break 350, and we could probably go a lot further. We just don't want to get in a lot of trouble. Frankly, we don't mind getting in trouble. We just can't afford the fines. Okay, that's really what it comes down to. So, for us, that early stage, we can reach that now with the technology that we developed as far as it is today. We can hit that today if we wanted to. We're going to pause. We're going to work on developing the IST numbers a little bit more robust, and then we'll start playing around with how far we can actually go. But yeah, right now the carbon is just over 350. All right. Well, thank you everybody for watching me stand up here and sweat in front of you. I really appreciate it. Always a pleasure.
Thank you very much, Alex. Really appreciate it. So we definitely appreciate Alex coming out. So next month, we're going to have a presentation about the coming economy of space resources. Presenter is David Hurst. That would be me. So I attended the Space Resources Roundtable in June, and there's some amazing things going on in the area of space resources. So I'll be talking to them, and hope to see you all then. Thanks for coming out, and please feel free to hang for a while and continue the conversation. Thank you.